This project looked like outright madness, even by the standards of post-war aviation. In Great Britain, engineers proposed a concept that resembled science fiction more than a real means of transport. It concerned a giant flying ship designed for 1,000 passengers with 5 decks, bars, restaurants, showers, and dozens of crew members serving passengers throughout the entire flight. It was assumed that such an apparatus could deliver a person to practically any point in the world while providing a level of comfort comparable to an ocean liner. However, there was something more behind this idea. The project developed in several variants, each of which became increasingly radical. Versions with jet engines, increased dimensions, a double hull, and even a nuclear power plant were considered. At the same time, all these developments were ultimately halted for one key reason. This project received the name Saunders Roe Queen and was intended as the flagship of the British aviation industry in the early 50s. It was created as a response to a request from transport companies interested in creating a flying ocean liner. According to the engineer's design, it was to be the largest passenger flying boat in history. A key feature of the project was not only its scale, but also the level of comfort. First-class passengers were expected to be provided with private bars, restaurants, and individual bathrooms. Lower-class passengers would be accommodated in compartments similar to railway carriages, where seats transformed into sleeping berths for 6 people in one room. At the same time, unlike modern aircraft, all passengers would have full-fledged seats and the ability to move freely throughout the plane during the flight, as happens on sea liners. Service was to be provided by a crew of 47 people, of whom 40 were flight attendants. They would work in shifts, ensuring service throughout the entire route. Inside the aircraft, elevators were planned to connect all decks, which further emphasized the similarity to a ship. Engineering solutions also matched the scale of the project. 24 Conway jet engines were placed high on the wings to avoid water spray. A dual air intake system was used, one for flight, the other for operation on water. The Rolls-Royce Conway engines themselves became the first turbofan engines used in aviation and were utilized on aircraft such as the Boeing 707, DC-8, and Vickers VC-10. It was assumed that this flying liner would perform long-haul routes, for example, from London to Sydney, with intermediate stops in Cairo, Karachi, Calcutta, Singapore, and Darwin. With successful implementation, the project could significantly change the perception of intercontinental flights. However, to understand why this did not happen, it is necessary to turn to the origins of the idea of flying boats itself and the company behind this project. In the 30s, crossing the ocean was a difficult task. Passengers either spent a week on a ship or used seaplanes, which were effectively flying yachts. Machines such as the Short Empire provided comfort comparable to a hotel. Imperial Airways operated these aircraft on routes throughout the British Empire, allowing passengers to move between continents with stops in coastal cities. The popularity of flying boats was explained by 2 factors. First, they did not depend on the primitive airfield infrastructure of that time, as they could use any suitable body of water. Second, their design allowed for the creation of larger aircraft with a large fuel supply and passenger capacity. This made them ideal for connecting remote colonies where full-fledged airports were absent. One of the most famous representatives of this class was the American Boeing 314 Clipper, which was distinguished by a high level of comfort and operated by Pan American. Passengers on board received full meals and conditions comparable to sea cruises. However, against the background of these already large machines, the engineers of Saunders Roe decided to go further and create a fundamentally new level of air transport. During the Second World War, the development of civil aviation slowed down significantly. However, flying boats, on the contrary, received additional development. Many British flying boats were used either on routes between London and New York or were converted into maritime patrol aircraft to fight submarines. As early as 1943, Saunders-Roe began work on a new project that was to become the largest all-metal flying boat of its time. The technical specifications provided for a weight of about 140 tons, a pressurized two-volume fuselage, and a wingspan of more than 65 meters. The maximum speed was estimated at approximately 540 kilometers per hour at an altitude of more than 11,000 meters, which required the use of cabin pressurization, rare for flying boats of that period. The flight range was to reach 8,000 kilometers, and the passenger capacity was over 100 people with an increased level of comfort. Around this same period, the British government initiated the development of a new transport and reconnaissance flying boat, inviting both Saunders-Roe and the Short Company to participate. The result was the Short Shetland project, which was built but ultimately recognized as unsuccessful. It turned out to be a compromise solution that did not fully meet either military or civilian requirements. For the Saunders-Roe engineers, this became an important experience, after which they focused on their own concept called the Princess. The Saunders-Roe Princess became the culmination of the development of flying boats. It was the largest all-metal machine of its class, with a double-deck pressurized cabin designed for approximately 105 passengers. A key feature was the power plant, 10 turboprop engines combined into 6 propeller groups. Such a scheme was considered extremely complex, but allowed for high power and ensured the takeoff of a heavy aircraft from the water. Regarding the level of comfort on board, a division into 2 classes was also provided. Tourist class resembled modern business class on short routes, while first-class passengers received separate cabins with 2 sleeping berths, access to a bar, and separate changing rooms. At the same time, the concept of a new infrastructure was being considered. The creation of large marine airports with covered docks was envisioned, where such aircraft could enter for maintenance. In 1946, BOAC showed interest in the project and signed a contract for the construction of 3 aircraft costing about £2,800,000 each. However, serious problems began already at the development stage. The project went over budget, deadlines shifted, and the new Proteus engines chosen for the aircraft created additional technical difficulties. In the 50s, the transition of aviation to jet propulsion began, and the company tried to adapt its developments to the new realities. Thus appeared the Duchess project, representing a smaller and redesigned version of the Princess. It was equipped with 6 de Havilland Ghost turbojet engines located in the wing root. The calculated maximum speed reached approximately 800 kilometers per hour, which was a significant figure for a flying boat. The design provided for a high-mounted wing with sweep and floats on the tips for stabilization on the water, which retracted in flight to reduce drag. The cabin was pressurized and air-conditioned, designed for approximately 74 passengers located in 2 compartments with a cargo hold between them for weight balancing. It was assumed that flights would be performed without long stops, so sleeping berths were not provided. Despite active promotion of the project and the demonstration of a model at the Farnborough Air Show, interest from airlines proved limited. Potential customers did not want to invest in development that had not yet reached the production stage, and without orders, the project could not be implemented. After 2 unsuccessful attempts, the company practically abandoned the idea of flying boats. However, it unexpectedly received a new request from a shipping company interested in creating a flying ocean liner. This became the starting point for the next, even larger stage of development. Based on previous work, Saunders-Roe engineers tried to radically increase the scale of the project. Initially, a version with doubled capacity based on the Duchess was considered. However, very quickly, the concept went beyond the limits of an ordinary aircraft. The project began to transform into a full-fledged flying ocean liner with several decks. The final configuration already provided for 5 levels, which effectively turned the apparatus into a hybrid of an aircraft and a sea vessel. It was this version that received the unofficial designation Queen and became the most ambitious of all those proposed. However, as the scale grew, the cost also increased sharply. The government and potential customers assessed the project as excessively expensive and risky. At that time, the priorities of the aviation industry were already shifting towards land-based aircraft and jetliners, so the idea of investing in such a complex and non-standard design did not receive support. After the refusal, the company tried to adapt its developments to the new conditions. One option was the conversion of the Princess into a land-based aircraft. It was planned to abandon the boat hull and replace it with a classic fuselage with landing gear for takeoff from concrete runways. It was also planned to modernize the engines, increasing their efficiency. However, this project also failed to arouse interest among customers. Then the engineers proposed an even more radical solution, a version with a nuclear power plant. The idea was to create an aircraft capable of staying in the air for a practically unlimited time. This project was considered in cooperation with the American side, but was ultimately rejected as excessively complex and potentially dangerous. The last attempt was the development of a version with a double hull, intended for the transportation of oversized cargo, including elements of the rocket program. The design provided for a significant increase in payload capacity due to 2 connected fuselages. Despite technical development, the project also failed to receive support. At this point, the series of attempts effectively ended. The reasons for abandoning flying boats in general were not so much related to specific technical problems as to the changing conditions in aviation. After the end of the Second World War, airports began to actively develop worldwide. This required significant expenditures and complicated operation. Even the already built copies of the Princess began to deteriorate during storage under the influence of the environment, which further reduced interest in their further use. Another factor was the increase in the reliability of aviation equipment. Previously, the possibility of landing on water was considered an important advantage for long-distance flights over the ocean. However, with the development of engines and the expansion of the airport network, this necessity practically disappeared. As a result, flying boats ceased to solve relevant problems. Ultimately, the Saunders-Roe projects became an example of how technologically advanced and ambitious developments can go unclaimed due to changes in external conditions. The concept of a flying ocean liner remained at the level of projects and prototypes, giving way to more practical solutions that better met the requirements of the time. Thus, the history of these projects did not come down to the failure of a specific design, but to a change in the very logic of aviation development. Everything that the Saunders-Roe engineers proposed was technically feasible, or at least on the verge of possible for its time. The problem was that the situation itself had changed. The boat hull increased weight, worsened aerodynamics, and complicated production. Corrosion protection systems added weight and required constant maintenance. Operation in salt water accelerated wear, which reduced the resource of the equipment and increased the cost of its maintenance. Simultaneously, land-based aircraft were becoming faster, more reliable, and more economical. Projects like the Queen turned out to be hostages of their own concept. From an engineering point of view, they represented an attempt to take an existing idea to the limit, increase scale, increase comfort, and expand functionality. However, the market was already moving in another direction. Passengers and airlines chose speed, regularity, and economy rather than the impossibility of landing in any bay and a level of comfort comparable to a sea cruise. As a result, even the most well-developed projects did not receive orders. Without customers, further development lost its meaning, and without mass production, any advantages remained theoretical. The company made attempts to adapt by switching to jet schemes, experimenting with alternative power plants, and even proposing radically new configurations. However, none of the solutions could change the general trend. The history of Saunders-Roe and its flying liners became an example of a technological dead end when development completely shifted to land-based aircraft. And projects like the Saunders-Roe Queen remained in history as an example of extremely ambitious but unclaimed solutions that did not so much outpace their time as lose it. On this, the development of the concept effectively stopped. The remaining prototypes of the Princess never found application and gradually fell into disrepair. Long-term storage in conditions of high humidity and exposure to the salt environment led to corrosion of the structures, which made their restoration economically impractical. In the end, they were dismantled, ending the history of the largest British flying boats. The Saunders-Roe Company itself also changed its direction of activity. After the closure of the program, it focused on other aviation and defense projects, gradually moving away from the development of civil flying boats. The accumulated experience in the field of complex aerodynamic and power solutions did not disappear, but was already applied in other segments of the industry. If we consider this project in a wider context, it shows the limits of development of a certain technological direction. The attempt to create a flying analog of an ocean liner relied on a logical continuation of existing solutions. However, it ignored fundamental changes in the environment. In conditions where speed and efficiency became key parameters, increasing size and complicating the design ceased to give competitive advantages. As a result, the Princess, Duchess, and Queen projects remained sequential stages of one idea, brought to the maximum but not finding application. Each subsequent variant tried to eliminate the shortcomings of the previous one. However, it faced the same limitations associated with the very nature of flying boats. Today, these developments are considered as part of aviation history, demonstrating how far engineering ambitions can go when resources and political support are available. At the same time, they also serve as an example that even the most well-thought-out and technologically complex projects can go unclaimed if they do not meet current conditions and market requirements. Ultimately, flying cruise liners never became a reality. The idea, which involved combining the capabilities of an aircraft and the comfort of a sea vessel, remained at the level of concepts and prototypes. The development of aviation followed a more rational path, where priority was given to speed, reliability, and economic efficiency, rather than the scale and level of comfort characteristic of ocean travel. No further attempts to return to such large-scale projects were made. By the mid-50s, it became finally clear that the era of flying boats in civil aviation had ended. Individual developments continued in the military sphere and specialized areas. However, the idea of using such machines for mass passenger transportation was recognized as unprofitable. Against this background, a new model of air transport finally took shape. Large airports with developed infrastructure, standardized routes, and jet aircraft became the basis of the global aviation network. Instead of versatility and the possibility of landing on water, the key advantages became speed, regularity of flights, and reduction of operational costs. The Saunders-Roe projects proved to be a transitional link between two eras. They absorbed the maximum achievements of the classic concept of flying boats, but appeared at a moment when this concept was already giving way to a new technological paradigm. That is why even the most advanced variants, including multi-level flying liners, were unable to find practical application. In the end, the history of flying cruise ships remained an example of how the development of technology depends not only on engineering capabilities, but also on external conditions. Changes in infrastructure, the emergence of new technologies, and a shift in economic priorities can completely devalue even the most ambitious projects. Despite the high level of development and significant investments, the concept of giant passenger flying boats ended at the stage of prototypes and sketches. It received no continuation and gave way to more efficient solutions that defined the look of modern aviation. However, the final disappearance of flying boats was associated not only with the development of infrastructure and the emergence of jet aviation. Operational problems played an important role, which became increasingly critical over time. Constant contact with seawater led to accelerated corrosion, complicated technical maintenance, and shortened the service life of the aircraft. The maintenance of such machines required significant resources, which made them economically disadvantageous compared to land-based counterparts. In addition, the reliability of aviation equipment increased. Previously, the possibility of landing on water was considered an important safety factor for long-distance flights over the ocean. However, with the development of engines and navigation systems, this necessity gradually disappeared. The appearance of additional airports along routes also reduced risks and made alternative solutions more preferable. As a result, flying boats ceased to perform the tasks for which they were created. They found themselves in a situation where their key advantages lost significance, while their disadvantages, on the contrary, became defining. This is why even such projects as the Saunders Roe Princess and subsequent developments were unable to find application. The history of flying boats ended not with a sharp refusal, but with a gradual displacement by more efficient technologies. This was a natural process reflecting the general direction of aviation development in the second half of the 20th century. And although the projects themselves were not implemented, they remained an important part of the engineering heritage, demonstrating the limits of development of one of the most unusual concepts in the history of aviation.